All right. Good morning. Good morning. Hopefully, I got my mic set up right here today. Sometimes I forget to make sure it's going through the proper channel here, but hopefully, this is good. All right. So I'll try to talk loud just in case the video is going through a different mic. But anyway, welcome. This is the Q&A live session that I'm doing today, and we're covering a topic, probably one of the biggest, most important skill sets you got to get pretty astute at doing or performing in algebra 1 or 2 because of the different things you're going to be tasked to do. Factoring is a big deal. We need to know how to factor a polynomial just for that sake. But then also when it comes to anticipating what are called x-intercepts, solutions, getting the roots of a graph, even predicting how long something is going to be airborne before it hits the ground, and answering lots of questions that we use with quadratics. Being able to factor is a huge skill because you can actually calculate it without looking at a graph. It's something that's going to be covered extensively. And then, like, for example, if you're doing simplifying of rational expressions later in the year, if you don't know how to factor, you're going to have a lot of trouble with that. So one of the most common types that I want to talk to you about, and I'll put it in the chat if it'll let me. Let's see. YouTube. All right. It's called factoring. I'm going to put this in the chat in case you're watching. Factoring quadratic trinomials. Okay. Factoring quadratic trinomials. So one of the types that we're going to look at least two different kinds. One of the types that we're going to look at is when you have what they call an a that's equal to 1. In other words, the first term in your polynomial has just simply an x squared or an n squared or a p squared. You're not going to see like 5p squared or 10p squared. It's just going to be the variable all by itself to the power 2. That's going to be your first term. When that's the case, there's a certain way that we factor those types. And you have an assignment. I'm just going to pick, I don't know, maybe a random one from this week's set of work. Let's say you have one like number 6 from the assignment. So that was b squared. Notice it's just a variable to the power 2. That's the first term. Minus 9b plus 14. Okay, plus 14. Let me see if I can draw that a little better. Then I'll show it on the camera so you guys can see my handwriting sometimes, I tell you. Okay, so taking a look here, this is kind of a good example of what you're looking at this week. We remember this is called a quadratic trinomial because there are 3 terms, trinomial, but it's quadratic because the degree of the entire polynomial is 2. Remember when we did classification of polynomials, you had to, how do I word this? I'm going to do a quick test on my mic. It's just getting on my nerves. Hello, hello. Hello, hello. I think this is it. Okay. So remember when we did the classification of polynomials, depending on the degree, you're going to have different names: linear, quadratic, cubic, quartic, just to name a few. But when it specifically comes to these trinomials, what we talked about last week and what you're doing for the assignment is you have 2 parentheses. You want to start off that way. And remember the b squared, that first term right there, you're going to expand into both parentheses. B squared really means b times b. That's how you got b squared in the first place. Okay, so b squared we split up into each binomial, each parenthesis, b and b times b is b squared. That's where that comes from. Then you got to really think about your multiplication facts and give it some thought, because remember we talked about how the outside number, I'm going to put an m there and an a here, the outside number, the number on the far right, you're trying to find numbers that multiply to it. But at the same time, those exact same numbers, there will be 2 of them. If you were to add them, they have to equal the middle coefficient. In this case, you're looking at -9 for that, right? So I put an A for add, an M for multiply here. Remember, if while you're learning, it's a great idea, give yourself just some, I don't know, some blanks here where you can figure out what goes in these spots, right? It's got to multiply to 14, but at the same time, if you added it, it's going to equal a -9, right? I pulled those numbers, of course, from the end and from the center here. And you got to think about it. Well, my suggestion, start with the multiplying piece. All right. Don't start with what adds, start with what multiplies, because there's only so many numbers that multiply to a number, and then you can test and see if they add after. So if I think about 14, for me, the first numbers that come to mind are 2 and 7. 2 times 7 does equal 14. Most people don't have any trouble with that. And if you think about it, 2 plus 7 does equal 9. Now, before you get too excited, you have a little bit of an issue here, because 2 plus 7 equals positive 9. This needs to be a negative 9. Notice this is a minus 9, so we look at this as a negative 9. 2 plus 7 does not equal negative 9, but there's an easy fix if you give it some thought, okay? Doesn't negative 2 times negative 7 also equal positive 14? Because a negative times a negative is a positive? Sure, it does. And a negative 2 plus a negative 7 equals a negative 9. So while it might appear to be one answer, if you do the test, remember it has to do both. It has to multiply to the one number, but if you took the same exact numbers, adding them up, it should equal the other. And now that we know it checked both boxes, so to speak, that's our winner. So since they're both negative, I'm going to put it in as minus 2 and minus 7. And the factors are considered what's in the parenthesis here. The factors of this trinomial are b minus 2 and b minus 7. All right. So this is factoring a quadratic trinomial. All right. So I kind of want to look at another one, but I might want to do one that has a combination, like maybe there's what's called a GCF that we have to factor out first. And then you got to do the trinomial. All right. So let me pull up one that does that. I'm going to pull, we could do so many different options here. Let's look at maybe number 16. Let's look at number 16 from the work, okay? Number 16 had a slightly different one where it was 3n squared minus 9n plus 6. I'm just writing that down real quick before I go back to the video. Okay, so this is the example from your assignment. But if you look at the last bottom half probably of the work, you'll notice they give you a warning, check for a GCF, okay? I only got one string on my guitar, as I always say, GCF, GCF, check for a GCF. I can't sing. But you need to always get in the mood of looking for GCFs when you're trying to factor any polynomial. Not every polynomial has a GCF other than one, okay? But some do. So your job is to check for it. So if you're taking a look right here, you notice that 3, negative 9, and 6, they're all divisible by 3. Here's a hint. A lot of times, the ones that have a GCF, that very first coefficient ends up being the GCF. A lot of times, not all the time, right? So if you think about it, 3 goes into all of those terms, right? So I'm going to say, before I do anything, I'm going to say my GCF is 3. Do a nice big wide parenthesis because you want to fit all 3 terms in there, right? And then we're going to divide it out. 3n squared divided by 3 is just n squared. Negative 9n divided by 3 is negative 3n, and positive 3 divided by 3 is a positive 2, all right? Be very careful that you divide correctly and pay attention to the signs. If you got a negative number divided by a positive, it'll be negative and so forth. Now, we're not done. We've just done phase 1. We factored out the GCF, all right? And so at this stage, we're really not even worried about the 3 on the outside. I want you to focus on what's in the parenthesis. If you notice in the parenthesis, this looks like the previous example we did. You got a trinomial, 1, 2, 3 terms. And so we're back to giving our 2 parentheses and asking what multiplies and adds, right? So you got n squared, you break it up into n and n. And then, of course, this time it's what multiplies to positive 2, but the same numbers have to, add to a negative 3, all right? Once you get really good at doing this, you don't have to do this little equations I do at the bottom. I just do that while we're learning to get you used to the concept. And then you'll probably get to the point where you can just do it in your head. Okay. So we're looking at the work and we're asking ourselves, what multiplies the 2 but adds the negative 3? Well, first off, 2 is a prime number. The only thing that multiplies the 2 is going to be 1 times 2. All right. So look at the bottom. If I did 1 times 2, that would equal positive 2. So it checks that box. But once again, 1 plus 2 doesn't equal a negative 3. 1 plus 2 equals a positive 3. We need it to be a negative 3. What are we going to do to fix that issue? It adds to the 3, but we got it. The sign has to be right. Well, usually when that's the case, it's just a matter of changing the signs of one or both of our numbers. And so I know that a negative 1 plus a negative 2 also, that will equal negative 3. That fixes that. And a negative 1 times a negative 2, and negative times a negative equals a positive. Anyway, so once again, that's the situation here, okay? Since we found out the combination, negative 1 and negative 2, we're just going to put it in the parentheses as n minus 1 and n minus 2. Now, here's the thing. Because we factored out a GCF when we started of 3, just make sure you leave 3 or bring down the 3 as part of your final factored solution, right? So just to clean it up so you don't get confused on what the answer is. The answer is really everything right here, okay? The 3 is factored out. You must let me know that. I need to have that included. But the other 2 factors, n minus 1 and n minus 2, are the factors. That's the final solution here, okay? So how do I know if this is right? If you really just want to feel better about it, remember factors, if you multiply them back together, are going to give you what you had originally. Just like 4 times 5 is 20. 4 times 5 is 20. That makes 5 and 4 factors of 20. You multiply 4 times 5, you get 20 again, right? Well, if you factored this correctly, if I multiply them back out, I should have originally what I had. So that's just a matter of distribution or FOIL, depending on what you want to call it. But that's a good method for checking your work. Okay. It's a good method for checking your work. Now, the last thing I'm going to cover, and then I'll end it. I'm going to keep it short and sweet. This is just a little extra refresher material so that it brings to memory, hopefully, everything we discussed in class. I'm going to do another one that's kind of the basic one. No GCF this time, right? But I just want to remind you what happens when the middle term appears to not have a coefficient. And I say appears because it actually does. Let me show you real fast. I just got to write it down. All right, there it is. I can't remember all this stuff, so I have to look at my notes. Okay, so if you look right here, you have another trinomial. And sometimes this is so simple that it gives kids trouble because of this particular situation in the center. This says r squared plus r minus 20. Well, the question is, okay, I know it needs to multiply to negative 20, the two numbers, but I'm confused. What's going on here? Well, don't forget, if you just see an r, you can go ahead and put a little 1 there. It's still the same thing as 1r, okay? They're not going to say 1r when you're looking at your examples. Your job is to know and recognize that, okay? So because of the fact that that's a 1r, I'm going to put, of course, my 2 variables there. And remember, I'm multiplying to get a negative 20, but I'm adding to get a positive 1. A negative 20 and a positive 1. Remember, when you're looking at the book, it's just going to look like this. R might make your head scratch for a second, but just put a little 1 there. Know that that's a 1R. Therefore, we're trying to figure out what adds to 1. You see? So looking at the work, negative 20, positive 1. You got to think about it. Would 10 and 2 work? I don't know. Let's try 10 times 2. Well, that multiplies the 20, but it needs to be negative 20, maybe negative 2. I don't know. But if I add that, doesn't equal 1. That equals positive 8. So sometimes you just have to try something and test it. That didn't work. What else gives me 20? What about 4 times 5? 4 times 5 gives me 20, but it needs to be negative 20. What can we do? Well, maybe if we made it a positive 4 and a negative 5. If I add 4 plus a negative 5, that equals negative 1. So the easy fix is change the number that had the negative sign. A negative 4 plus 5 times 5 equals a negative 20 as well. But guess what? Negative 4 plus positive 5 does add to a positive 1. So that's my winning combination. So when I'm putting that in there, just make sure you make the 4 minus, make the 5 plus, and you're done. R minus 4 times R plus 5 is your answer. Chris, doesn't matter which parenthesis I put first. No, it does not. As long as one of them's an R minus 4 and one's an R plus 5, doesn't matter which one comes first. Okay, so take a good hard look at that. This is factoring quadratic trinomials when the a is equal to 1. In other words, when you just have r squared or x squared, you don't really have coefficients in front, except if in the case that there's a GCF, of course, then sometimes that will occur. But anyway, hopefully this reminds you of what we discussed, gives you a little bit more clarity, and will help you be successful when you're going through your work. You got to do the math to learn the math. If you need tutoring help, or if you see this video and you want to I don't know, sign up to get some added support. Maybe you're a homeschooling parent, family who's overwhelmed, or you haven't been in high school math in years, so you never did good in the first place. You need some help. Go to morrismodel.com, and you can book a tutoring slot, or you can set up a free strategy session call with me to figure out what your needs are. We have some 10-week courses, some special other programs that could be a good fit depending on your situation, and you can go there and possibly get the perfect solution for your kid. We're going to fill in learning gaps. We're going to give them a good, solid foundation and hopefully get them prepared for the next level of mathematics that they're entering into. So anyway, that's all I got to say on this one. Have a good time doing the math, learning the math, and getting more proficient. You can do this. I can help. I'll catch you on the next one. Peace.